Welcome back to the TheMathsBro A-Level series, where we go through a bunch of A-Level questions to help you ace your exams. Straight away, looking at this question, we can tell that it involves differentiation and integration. Differentiation, integration, and trig are the big three topics when it comes to A-Level maths, so we have to nail them. Let's get straight into this question. A curve has the equation y equals f of x, cool, x is greater than or equal to 0. Given that the derivative of f of x is this expression here, expression of course involving a and b constants. Also this information, so the curve has a stationary point at this point, that's quite useful, and the curve meets the y-axis at -5, so its y-intercept is -5. We need to find out what f of x is. F of x of course being the integral of the derivative, f dash of x, or f prime, whatever you want to call it, but we need to figure out what these a and b constants are. So let's work with the information that we know. The curve has a stationary point at 4, 3. Of course, a stationary point is where the derivative is 0. Momentarily at that point, the gradient is 0. So this expression equals 0 at the point 4, 3, which is your x and y coordinate. We know that x equals 4, so we can sub that in. Okay, so we've derived an equation that involves a and b. Okay, let's see what else we can do. We're trying to figure out what f of x is, and of course that's the integral of f dash x. So that's the integral of 4x plus a. I'm going to write x to the power of half instead of root because we always want to work with indices, plus b with respect to x. Okay, simple integral. With integrals, of course, we increase the power of x by 1 and then divide by the new power. So 4x increases the power to 2, divide by 2, plus ax. So increase the power by 1, so 3 to 2 divided by 3 over 2, plus b with constants, we just add an x, and of course we have to plus a c constant here, but the question actually gives us the y-intercept of -5, so instead here we can just write -5, and just with a bit of cleaning up, that is essentially our f of x. But of course we need to figure out what a and b are. So this is essentially our curve. Let's just remember early in the question they actually gave us a point that was on the curve, a coordinate of 4, 3, which means we can sub this x and y into our equation, which would be valid because of course the point is on the curve, and we'll be left with an equation with an a and b in it, and we already have another one of those which we can use for simultaneous equations to find out what a and b are, which would give us our final result. So essentially as I'm working, I'm kind of thinking what I can do ahead, which would lead me to my final result, which is what I'm looking for. So this is my second equation. So here are my two equations. Let's work out what a and b are. You can use any method you want, but I'll probably just substitute the b in. So I'll make b the subject on this side and then just sub it in here, which gives me my result for a, which is -15. Then I'll just put this back into this equation to figure out what my b is. This was my equation for the curve. Let's plug in the a and b values, clean it up, and this is our final answer. To find f of x in the simplest form, which is what we've done here. You get a mark to work out the first equation, 2 marks to integrate, and 1 mark to use the y-intercept, 1 mark to find out what a and b are, and the last mark to present your final answer in the simplest form. Again, you're going to have to use differentiation and integration quite a lot at A-level. Sometimes you get questions like this where you have a mix of both. So you need to make sure that you're good at it to achieve those high marks. Anyways, let me know what else I should cover in this series, and we are done.